Hey y'all, so last time we talked a little bit about these exponent properties, right? We have the product rule, the power rule, the quotient rule, and then the negative exponent rule. So as we start to look at logarithms, which we've talked about the relationship between logarithms and exponentials, we're going to see some pretty similar rules. So as we're working with logs in our algebra, we need to be able to manipulate them just like we did with exponents. So what you're going to be doing for this assignment is you'll have a couple questions about translating logs. So I gave you some examples there. We talked about this in class. If you're still confused, you can go back to the last class and watch that recap video. Then you'll have a couple problems expanding logs and condensing logs, and that's what we're going to be talking about today. There's also going to be a cheat sheet, which is what I'm going to be filling out with you here. That'll be attached to the activity as well. And then I'll do a couple more example problems toward the end. Okay, so the product rule of logarithms tells us that if I have a log and then inside the argument of the log, so remember that's this value here, so inside this argument, if there's two things being multiplied, so if we have two factors in here, we can actually split the log into two pieces where we have each of those factors separated and we add the logs together. That's the product rule. So this can be really useful when we're solving something algebraically. For example, here, this is problem 1, that's a parentheses. It says log base 2 of 8x. So I can't tell you what exponent gives you 8x, but I can tell you what exponent of 2 would give us 8. So if we could split this log apart, we can make a little progress toward figuring this out. So we've got two things multiplied together, x times 8. So I can take this log and split it apart. Log base 2 of 8 plus log base 2 of x. Notice the base for both logs is whatever the base was when we started. Now we have this expanded log, which is pretty much all we're going to do, although I can simplify this a little bit. I've got log base 2 of 8. So since I'm dealing with all numbers here, I can actually solve this. 2 to what power gives me 8? 3. Okay, and if you're still struggling to wrap your head around logs, remember we can translate this, right? 2 to some power gives us 8. We can also throw this kind of thing into the calculator. So if I throw this log base 2 of 8, I'll get 3. So if you're still struggling a little bit with wrapping your head around that, we can always check ourselves on the calculator. All right, so this is all I'm doing, just taking this single log and expanding it into as many parts as I can. Let's do another one here, number 2. So I have log base 4 of 16y, so I'm going to split this up, log base 4 of 16 plus log base 4 of y. My g's, my 4's, my y's all kind of look the same, sorry. Okay, so over here I've got 4 to some power gives me 16. Well, 4 squared gives me 16. And then over here there's nothing I can do with this part because I don't know what y is. Okay, so the product rule rather allows us to take an argument that has multiplication and split that apart into two logs being added together. Let's take a look at the sort of opposite effect we can use. So not only can we use this rule to expand logs, we can actually use it to put logs together. So let's say I had two logs being added together and they have the same base. I can actually smush those logs into one. So looking at an example here, I got log base 3 of 7 plus log base 3 of x. So I'm going to rewrite this as one log. Again, the base is the same as what it was when we combined. And then inside of here, inside my argument, I'm going to have 7 times x. Notice I'm using parentheses here. We don't necessarily have to do that. If I just wrote log base 3 of 7x, that's probably okay. But I just want to make it really clear that the 7 and the x are inside the log, right? Instead of log base 7, or sorry, log base 3 of 7 times x. So the parentheses make this really clear that the x is within the log. All right, the next one, 10 here. We have log 8 plus log y. Notice we don't see a base here. That's because we're dealing with a common log. We do have a base. It's 10. Okay, so log base 10, we don't write the base. Okay, so again, I can just shove these together, 8 and y. Since we're adding the two logs of the same base, we can make this a single log with 8y as the argument. Again, I'm going to throw parentheses around there just to make this really clear. And we don't need a base because we're dealing with common log. If I wanted to put 10 there, I could, but we don't have to. Okie dokie. So that's the product rule, and you'll have this cheat sheet available so you can review this as we go. Next is the quotient rule. So just like with exponents, when we see division, we can think of that as sort of subtraction, right? Kind of the same as our quotient rule with exponentials. Okay, so if I have two terms being divided inside my argument, inside the log, then I can split it up into a log minus a log, okay? Log of the top minus log of the bottom. So here we have log base 4 of x over 2y. So I'm going to split this into two logs. Log of the top minus log of the bottom. Okay, so notice again, I'm keeping the same base we started with, log base 4 for all of this. And there's more I can do here. I've split up the top and the bottom, the numerator and the denominator here, but I still have 2y, right? We still have some multiplication going on here, 2 times y inside this log. So we can actually split this up even more. You want to be really careful though when you're splitting a denominator like this, because this subtraction sign is going to apply to my expansion. This is where things get a little bit tricky. So log base 4 of 2 plus log base 4 of y. So notice that we basically took this right here and we used our expansion rule that we did earlier. And because this whole thing is getting expanded into 2 logs being added, that negative applies to all of it. Okay, if we wanted to, we could rewrite this 4 to some power gives me 2. 4 to the 1/2 power would give me 2, but I think this is fine the way it is. Or we could distribute the negative, so I could rewrite this as minus that and minus this, right, if I just distribute that negative, and then we don't need parentheses anymore. But either way is okay. Okay, finally I've got log base 5 of 125 over x. So again, I'm going to split this up. Log base 5 of 125 minus log base 5 of x. Okay, so I got 5 to some power gives me 125. 5 times 5 is 25, times 5 again is 125, so that's just 3. Okay, and just like with the product rule, we can go the other direction with this. If I have 2 logs being subtracted, and as long as those logs have the same base, then I can put them together. Okay, so this is pretty straightforward. Log of 3 minus log of x becomes log of 3 over x, all of which have a base of 2. Over here we have some common logs, so I can put these together. Log of x over y. Okay, again, the quotient rule can be used in either direction. We can use it to condense our logs into a single log or to expand it into several. And both have their uses depending on what we're trying to do with our algebra. If we're trying to solve for this x, this x, it might be useful to split those logs apart. That way we can go ahead and evaluate this, turn it into a number, and we can get this x alone a lot easier. So you can imagine how this is going to be helpful when we see the algebra of all this come together. Sweet. Okay, just like with exponents, we have something called the power rule. So this one's pretty interesting. Here we have log of m to the nth power. So we can take that n, that exponent, and bring it out front. So looking at this example here, I've got log base 3 of x squared. So log base 3 of x squared. I can take this exponent, this 2, and I can bring it down front. So saying log of x squared is the same thing as saying 2 log of x. So it becomes 2 times log of x, log base 3. Okay, so again, we can do that here. We can take this 6 and bring it down. So I'm going to do that first. We get 6 log base 2 of 5x. Just parentheses, make sure everyone knows that 5x is inside the log. And now we can do some expansion. We can split this up. So notice that this 6 applied to both the 5 and the x. So we're going to make sure that's true as well when we expand this. So it's going to be 6, and then I'm going to expand my log. Log base 2 of 5 plus log base 2 of x. 2 to some power is going to give us 5. That's nothing obvious, so we can just leave it in log form. And again, you always want to check when you have a log. When you have a log with just numbers, you should check and see, can we just simplify this? But 2 to the 2 point something power, that's not any simpler. Okay, just like with all the other rules, this can be done in reverse. We can use this rule to condense some logs. So here I have 3 times log base 2 of x. I can take that number that's being multiplied in front and stick it inside the log as an exponent. So log base 2 of x cubed. Same deal here. We can take this 2 and put it inside our argument. You want to be pretty careful here though, because we have 2 pieces. We have a 4 and an x in here. So that 2, that exponent, is going to apply to both. So we can either leave it like this and just use parentheses to make it very clear that the squared goes with the 4 and the x, or if we want to be fancy, we can simplify this a little bit and just say 16x squared. Right? Just go ahead and do that. All right. So when you look at your homework or your async work here, you're going to see some examples that kind of mix these things together. And we kind of already seen this, but let's take a look at a few more here. So I've got log of 1000x squared, and they want me to expand the logarithm. So I'm going to use the product rule to break this apart, and then I'm going to use the power rule as well to deal with this exponent. So first thing I've got in this argument, I've got 1000 times x squared. So I'm going to product rule that. I'm going to split it up into log of 1000 plus log of x squared. Okay, there's a lot more we can do here. So first thing I see is I've got log of just a number. So the answer here, or the simplified form of this, is just some number. Remember, this is common log, so my base is 10. 10 to some power is giving me 1000. Well, 10, 100, 1000. So this is just 3. And again, we can throw that into a calculator if we're feeling unsure, but you should be able to think through this after you get that practice down translating. And then I can use my power rule here to bring that 2 down. 3 plus 2 log of x. All right, let's try another one. Running out of room here, so I'm going to switch colors to make this more clear. Okay, so first thing I see is I got division in here, so I'm going to use my quotient rule to break that up first. So log base 2 of 8x to the 4th minus log base 2 of y. Cool. So notice that I was dividing, so I switched this to log minus log. See if you can finish this one off. Maybe pause the video and check as I go through it. Okay, so there's more to be done here. I can split this up. Notice that I do have an exponent here. I have x to the 4th power, but the 4th power is not involved with the 8, right? It's just on that x. So I'm going to split this first. Log base 2 of 8 plus, and then I'm going to go ahead and bring that 4 down as well. Log base 2x. Notice log base 2 of x to the 4th became 4 log base 2 of x using that power rule. And we still have this guy hanging out over here. Sweet. So again, the advantage to this we're not going to see until we start doing some algebra. We're not going to do a ton in this class, but into pre-calculus we will see some of this pop back up again. But I have this one argument that has numbers and x's and y's all mixed together, and by the power of expansion I can isolate my number. So over here I've got 2 to what power gives me 8? That's just 3. 2 to the 3rd power gives me 8. And then I've got my x part, my y part, so we can solve from here if we had more information. And finally, we can condense our logs using these same rules. So First, I noticed that I'm multiplying my logs. Right, I got a 2 here, 5 here. So I'm going to use my power rule to get these numbers inside the log. So I get log of x squared plus log y to the 5th. Now I'm going to use my product rule to condense this. We can write this as one single log. Inside that argument, we're going to have x squared y to the 5th. Okay, and the last one here, got a lot going on. So the first thing I notice, again, I've got these numbers out front, so I want to go get those inside the log to start. I'm going to switch colors here again. So log of xy to the 4th power minus log of y to the 3rd power. Okay, and now I've got some subtraction here. So I'm going to use my quotient rule to get this all into one log. And on top is going to be this x y to the 4th, and on the bottom y to the 3rd. And again, this is getting a little bit confusing, so I'm going to use some big parentheses to make sure that we know that all of this is inside the log. Again, notice it's a common log because there's no base shown. Okay, so this is pretty good. This is all right, but we can do a little bit better with this. We got y's on top and bottom. Some of those should cancel out. So let's finish this off. So on top, I've got x to the 4th power, y to the 4th power. On bottom, I've got y to the 3rd power. So we got 3 y's on bottom and 4 y's on top. So 3 of those are going to cancel out using our exponent quotient rule. We get x to the 4th y. Write this a little bit better. X to the 4th y is our argument. Okay, so this simplified pretty nicely. Okay, this is a lot. You only have a couple problems on the async activity. So you've got these first couple, which is just translating the log. Then you have 4 problems with expansion, and then 4 problems with condensing. You'll notice that the first couple are pretty easy. Right, we just have 4 times x. That's just going to split apart into 4 and x, right? Log 4 plus log x. And they get a little more complicated as we go.